Learning target 6.13, I can define a reversible reaction. Okay. A reversible reaction is one where your reactants turn into products and your products are turning back into reactants. Okay. So an example of this would be, let's say, H2 plus O2 turns into H2O. Right, let's go ahead and balance this. So this is your forward reaction. Now, in this reaction, you can also see it go the other way. So this is your reverse reaction. We would say, well, my 2H2O will turn into or decompose into 2H2 and O2. Right? Your reactants turn to products and your products turn to reactants. We don't always write it like this because this is time consuming and clunky. So the way we sort of denote a reversible reaction is with a double arrow. So if you see something like this, one arrow going that way, one arrow going that way, you will know that we're talking about a reversible reaction. So if I'm just going to label this, this is your forward, and this is your reverse. Okay? And one of the key things is that the reactants and the products that you have, my reactants and my products, are never used up. They just keep going back and forth and back and forth. In fact, they are both constantly reacting and being produced, and this will lead to equilibrium over time. I mean, it's going to take a while, but eventually you're going to get to equilibrium. Okay, so let's go ahead and take a look at our sample question. In a reversible reaction, which of the following statements is not true? Okay, let's take a look. So we're looking for something that is false. Okay. In a reversible reaction, is the reaction in both directions occurring at the same time? Yes, right? You're going back and forth at the same time. This is a true statement. All right, let's actually jump to the last one. Equilibrium is established when the rates of forward and reverse reactions are equal. Well, I didn't discuss this in this particular learning target, but yes, right? Equilibrium is established when the rates of forward and reverse reactions are equal. That is a true statement. The reaction written from right to left is the reverse reaction. That is correct. If you recall, right, in this double arrow 2H2O, when you write it from the right-hand side, this is your right hand, right to left, that's called your reverse reaction. That's true. Then this must be false, but let's go over why. The rate of the forward reaction is equal to the rate of the reverse reaction, right? In a reversible reaction, this is not a true statement. This will only become a true statement when you reach equilibrium.